I plan to give 5 lectures about the optics, and today will be our 3rd lectures. Also, as a reminder, there will be a quiz today based on the chapter 25, and it is posted on the Moodle already, so please give a check. So today we are going to continue our discussion about the refraction of the light. And now I'm going to teach you that how to use the principle I showed you for the mirror, for the ray tracing, but now it is for the lenses. So let's briefly review what we have learned before. First, the reflection of light. So the reflections happens in the mirrors. So you will see that later on, the similar thing will happen in the lens, but in the lens, the light can penetrate through. So not just the reflections, the light can be refracted. So the law of the reflection simply tells you that is the angle of the incidence, which is compared with the normal line, is the same as the angle of the reflections. And how did you draw the normal line? So no matter your surface is curved or not, the normal line is always perpendicular to the surface. So if it is curved, then it should be perpendicular at that point of the incident. And we also introduce you the concept of the refraction of the light. So this kind of refraction happens is because the speed of light is different in different kind of media. So therefore, if you moving at a different speed, the light will be bended. But how it is bended? This is our main focus today. So I show you, I already give you an explanation last time, but today I find out that there is a very good illustration here. So consider this is 2 tires connected by an axis. So if they are all originally rotating in the air, this is the left tire and this is the right tire. So if they are both rotating in the air, they are moving and rotating at the same velocity. But now, if you put a glass block here, so apparently during the rotation, the left tire will interact with the glass surface. So which means this part of the tires will rotate differently compared with the right tires. So you can use the concept of friction. So apparently the friction between the glass and the tire is smaller. So therefore, the rotational speed of the left tire will become slower. But the right tire is still in the area, so they will move at original speed. So consider one is moving slower and the other one is moving faster. So therefore, you will see that the whole object, the direction of the movement will be bended. It is because of the difference of the velocity of the speed. So this is a very good illustration, is that when the light entering to the different materials, because the speed is different in the air and in some gas or some glass material, so it will be bended. So originally this is the direction of the propagation, but now the direction of propagation is bended. So this is very important concept about the refraction and why it happens. So if you treat this one as a case, so let's say this is a glass. So glass is more dense material than the air. And you have the incident ray interact with the surface here. And the dashed line is the line perpendicular to the surface. So you have angle A. And now this ray, the light or the ray will be refracted. So this is angle B. And I have teach you that the angle A and B can be connected through the Snell's law. So what is Snell's law? So the Snell's law is that this is a coefficient in the media 1, and N is the coefficient in media 2. And this index of coefficients is determined in terms of the speed of light divided by the velocity in that material. So I already showed you the definition in the previous lecture, so please give a check. And the theta 1 is the incident angle, theta 2 is the refracted angle. So let's try to take a look about these two different materials. if you have air and water, and water is more dense than air, so originally the incident angle is 60, and the index of refraction N1 is 1 for the air. And for N2 in the water, the value is bigger than 1. So apparently, as I already explained to you, because N2 is bigger than 1, therefore the theta 2 will be smaller than 60 degrees. And why it is 40.6, it is determined by the coefficient index of the refractions. Apparently, if you change the material for the N2, you change the coefficient of N2, so the theta 2 will be different. And the glass is more dense than water, so the angle of the refraction is even smaller. So what do you have learned so far? So here actually they imply is that the velocity of the light in the water will become slower. And if they become slower, they will be bended to the normal line. But because the glass is more dense than water, so the speed of light is even slower in the glass. So they will be bended even more toward to the normal line. So even though I already give you an explanation why the velocity will become slower in the medium with higher index of refractions, but let's try to propose another kind of explanation. So in the chapter 25, I mentioned that the light is a very unique wave. The propagation of the light doesn't depend on the medium, which means they can propagate in the vacuum. So what I mean is that the more material or media involved during the propagation of the light, the more distractions of the speed. So which means that when the light propagates in the air, they have to interact with the particles in between, in the air molecules. So this will slow it down. And if it is in the water, more particles there. So therefore, when the light propagates in the water, the speed will even slower. So the concept is that the higher the density, the slower of the speed of light in the material. But until this point, I want to remind you one thing. In the chapter 25, I told you that the speed of light is a constant, no matter what kind of frequency it is. This is definitely correct. But when I say that the constant is in the same medium, if it is propagating in the vacuum, the value is 3 times 10 to the power of 8. This value is only for the vacuum, and it is a constant. If it is in the water, it is also the constant. But now this value is smaller, but still a constant. So be very careful. Please pay attention to this point. The speed of light is a constant. So now let's take a look about these slides. So this is a combination of the 2 previous slides. So if you put the glasses in the air and the water, now you have an incident angle 60, and this is refracted angle. So this angle can be found through the Snell's law. And now the light will propagate in the glass and hit another surface. Then now they try to leave the glass and enter to the area. And did you notice that now here is that actually the scenario in this interface is the light is entering to a media with lower index of refractions. So which means it is back to the air again. So the speed of light will be increased. So once again, this is your surface. So you draw the normal line. So now the light will be bended away from the normal line. So let me emphasize again. When you entering the glass, the light was bended toward to the normal line. But when you leave the glass, try to enter to the air, now the light is bended away from the normal line. And the reason is because when you enter into the glass, the velocity becomes slower. But now when you leaving, the velocity becomes faster. That is the reason, and this is a very important physics. So now let's try to summarize the basic property of the refractions. So if you have a ray entering to a media and where the speed decreases, it will bend it toward to the normal line. If the speed increases in that media, it bends it away from the normal line. This is basically what I just said. And if there is no change of the index of refractions, then there is no refraction. And finally, this is a very important thing, is that if there is a ray that goes from one media to another one, so there's a change of the index of refraction, but now the directions is along the normal line, which is if you have the incident light following the normal line, only this particular direction, the light will not be refracted, because you don't even have the angle to refract it. Yeah? So this is what they mean, regardless of the index of refractions. So these four summarize the four most important results we just mentioned. And they are actually very interesting application of the reflections. And mirage is actually one of the famous examples. So when people walking in the desert, they will have illusions, say, okay, they can find the water pond or the trees in front of them. So they keep following that directions, but they can never find anything. And the reason is simply due to the refractions. So consider this is a real trees when you are walking in the desert. So in the desert, the temperature is very hot. Yeah? So because of the temperature of the surface is pretty hot. However, when you getting higher and higher, the air will become cooler and cooler. So what does that mean? Do you remember I told you that the temperature plays a very crucial role? So now, because the temperature in upper level of the air is different, it is lower, so it is more dense. So if it is more dense, what does it mean? The light travels slower there. So now, if there's light propagate out from the point T, from the trees, so they penetrate downward. Now, this is the normal line. So you can draw this is a normal line. This is a normal line here. The dashed line here is a normal line, and this is an interface. So you can see you are moving from a denser material to the less rare dense material. So if this is a normal line, then the light will be bended away from the normal line. Agree? So let's take a look again for the light from the tree. And now you are entering to a regions from a higher density to a lower density. And this is the dashed line here is a normal line. So therefore, the reflected light will be bended away. Therefore, the same process keep happening and keep reflected. Then eventually, the light entering to your eyes will be completely bended. So you will receive a light is in this direction from the trees. However, your eyes always produce an illusion saying, okay, I receive a light from this direction. So they will automatically trace backward through the dashed line. And the image will be formed here that there is a tree here. So you say, okay, now there's a tree in this direction. But in fact, it is in this direction. So you are going to walk into a wrong direction forever and cannot find the trees. And this is the concept of the mirage. And the similar thing in the city is that in the very hot summer, you can see the surface of the road is so hot. So hot. So you can even see the image blurred and the blur, and you cannot see the image of car clearly. This is actually another example of a mirage.